hidden ocean beneath the Earth. Do we really know what lies beneath our feet? The Earth we walk on every day seems quite special to the outside world. Blue oceans, vast continents, and a surface teeming with life. But that's only the tip of the iceberg. Because humanity knows far less about the depths of the planet it inhabits than it thinks. The deepest borehole ever drilled, the Kola Superdeep well in Russia, only reached a depth of about 12 kilometers. While these results may seem impressive, considering the Earth's radius of approximately 6,371 kilometers, this is no different than lightly scratching the peel of an apple. A large part of our planet is a mysterious world we cannot directly reach, only examine directly. Now imagine, what would you think if you were told that the depths of the Earth, more than all its oceans combined, could be hidden right beneath our feet? At first glance, it would seem like science fiction. Because kilometers below the surface, at temperatures reaching thousands of degrees, lies a vast expanse of water. The pressure is hundreds of thousands of times greater than that at the surface. The existence of such water seems almost impossible, but science sometimes reveals the most surprising facts. Recent research suggests that a reservoir of unimaginable water may exist deep within the Earth. This expansion, in general, excites not only geologists, but also planetary scientists, climate researchers, and scientists investigating the origins of migration. However, there's an important detail here. This isn't a dark, underground ocean where you can swim in submarines. No giant waves. No whales. No water caves stretching for miles. The reality is far more extraordinary. This water is trapped atom by atom within the crystal structure of minerals deep within the Earth. This visible reservoir, hidden from view for millions of years, may be one of the planet's greatest secrets. So how did scientists discover that water exists at such vast, kilometer-deep depths that they can reach? How do they discover something nobody else has ever seen, without descending into the Earth's interior? The answer lay in the great earthquake of our planet. Because the Earth, with every earthquake, tells us what is happening within ourselves. And when scientists managed to decipher this silent language, humanity perhaps encountered one of the most astonishing relationships and characteristics of the planet's state. How did scientists discover this? We can't directly see what's hundreds of kilometers below the Earth's surface. Even the deepest man-made hole drilled so far only reached about 12 kilometers. Yet, the water thought to be hidden in the mantle is located approximately 410 to 660 kilometers below the surface. So how did scientists discover something so deep? The answer lies in earthquakes. When an earthquake occurs, giant waves of energy pass through the Earth's interior. These waves speed up, slow down, or change direction depending on the material they pass through. Geophysicists map the planet's internal structure like a CT scan by comparing data from seismometers around the world. In the early 2000s, researchers noticed an interesting detail. At a certain depth in the mantle, some seismic waves were traveling slower than expected. This suggested the presence of an unusual substance there. Initially, it was thought to be simply due to different types of rock. But laboratory experiments opened another door. Scientists compressed minerals using special presses that mimic the pressure in the mantle. Then they studied how water molecules were embedded within these minerals. The most striking result came with a mineral called ringwoodite. Ringwoodite is a mineral that is almost never found on the surface but forms deep within the mantle. Its crystal structure can trap water at the atomic level. So, this isn't a liquid sea. It's a vast reservoir of water locked within the rocks. In 2014, a sample of ringwoodite was found inside a small diamond mined in Brazil. This discovery became one of the strongest pieces of evidence yet that water actually exists in the mantle, because the diamond had carried the mineral from its depths to the surface, preserving it along the way. Now scientists had two independent pieces of evidence: the behavior of seismic waves and the water carrying deep mantle minerals. Combined, these two significantly strengthened the idea that there is a much larger water cycle within the Earth than we previously thought. But the main question remains unanswered. If there is so much water, how large could the actual amount be? Not an ocean, but bigger than an ocean. Until now, we've used the phrase, underground ocean. But there's an important distinction here. There isn't a sea swirling in vast voids within the mantle. Water is bound to the crystalline structure of rocks and minerals. Yet, its quantity can be so vast that, if released, it could approach the total volume of all the surface oceans combined. Scientists are focusing particularly on the transition zone between 410 and 660 kilometers. Minerals at this depth can hold water under high pressure. Even if only a small fraction of these minerals contain water, the total amount becomes astonishing. To understand this, consider a simple analogy. You have a giant sheet of rock that acts like a sponge. Even if the rock looks dry, it has absorbed water at the atomic level. When this is repeated over millions of cubic kilometers, an invisible ocean emerges. This discovery also changes the story of Earth's water. For a long time, it was thought that most of the oceans arrived via comets and asteroids. Now, some researchers believe that a significant portion of the water may have been hidden in the Earth's inner layers since its formation. Even more interestingly, this water isn't static. Over millions of years, it's been transported downwards by plate tectonics, stored in the mantle, and returned to the surface through volcanism. So there's a massive, slow but continuous water cycle between the oceans and the mantle. In other words, a water molecule we see on the shore today may have been trapped inside a mineral hundreds of kilometers deep millions of years ago. So how does this hidden reserve affect the future of Earth and the origin of life? What does this water tell us about life? Water is one of the most critical components for the emergence of life on Earth. That's why scientists have long asked, did water come to our planet from outside, or was it already present within Earth? The hidden water reserve in the mantle strengthens the second possibility. If Earth's interior has contained large amounts of water from the beginning, the formation of oceans may be a far more complex process than we thought. This discovery has another implication. Water lowers the melting point of rocks. The more water there is in the mantle, the more differently volcanic activity and plate movements behave. So this invisible water deep within the Earth may be influencing many processes, from continental movement to mountain formation. Some researchers even believe that this deep water cycle played a significant role in keeping Earth habitable for billions of years. Because some of the water may have been stored in the mantle, balancing extreme changes on the surface. So, is there life there? Most likely not. Temperatures at these depths reach thousands of degrees, and pressures are hundreds of thousands of times greater than on the surface. But the presence of water suggests that the basic components of life may be far more widespread than we thought. This idea is important not only for Earth, but for other planets as well. Even if a planet's surface doesn't show oceans, its depths may contain minerals that carry water. Perhaps we're looking in the wrong place when searching for habitable worlds. And now we come to the final question. Why does this discovery radically change how we see Earth? Our biggest misconception about Earth: most of us think of the Earth as two-layered, oceans on top, rocks below. But modern geology shows us a far more complex picture. The surface seas may only be the tip of the iceberg of the planet's water story. If the transition zone in the mantle truly contains as much water as the oceans, then the Earth's largest reservoir of water is not before our eyes, but hidden hundreds of kilometers beneath our feet. We will never be able to discover this water with submarines, because it remains locked within the atomic structure of crystals. Yet its influence is everywhere. In the gases ejected by volcanoes, in the movement of tectonic plates, in the chemistry of the oceans, and perhaps in the continuation of life for billions of years. This discovery teaches us an important lesson. The true face of a planet cannot be understood by looking only at its surface. The Earth's depths are still largely unexplored. And perhaps the greatest ocean is not the one we see on maps, but the one hidden so deep that no human can see it directly. Next time you look at the sea, remember this: the water you see may be only a small part of the entire water story of the world. The real ocean awaits silently beneath our feet.